Okay, we are back. Can you hear me?
Yes,
Hello?
Professor.
Yes, Professor. We
All
can
right,
hear
so
you.
normality we checked thoroughly. I hope you know if you see a variable density function, you will be able to find, and also you will be able to standardize a variable. Never forget that formula I told you. Let's do some problems. I mean, you take your pencil and notebook to do this, okay? Let's do this problem. X is, okay, first one, let us do together, and then other ones I'll let you do. I'll ask one by one. So X is normally distributed. X is normally distributed with mean mu equals 30, and variance and standard deviation is given sigma 4. Now, what is the problem? Very simple. What is the probability that the x, the variable x, uh, is less than 40? Another one, what is the probability that x is greater than 21? And last one, what is the probability that x lies between 30 and 35? Obviously, we know mean, we know standard deviation, we can find the density function and then we integrate it and we find. However, we know that the easy way to solve this problem is to do what? You standardize the variable and then look at the table. So today, what we are going to do is we are going to do these simple examples. I'll do first one, let's say, and then I'll show the table from our textbook. Then I'll let you do other examples. So first one, let's focus on this. X is normally distributed with mean 30, standard deviation 4. How do you standardize that? The standardized variable z would be, remember, x minus mean, x minus mu, mean, divided by what?
Sigma.
Divided by
Standard
6.
deviation.
And that gives you, what is the x value we are looking at?
Less than 40.
Less than 40. So let's say 40 minus
30 divided by 4.
30 divided by
4.
4. That gives you what?
2.5.
2.5. So basically, probability that x is less than 40 is same as probability that what? Is same as probability that z less than, is it 2.5 here?
2.5.
Yes. 0.5.
Yes.
2.5. So,
Is it 68%?
so x less than 40. What do? You convert that x into standardized variable, and this is the formula. By the way, what is mu? What is sigma?
Mu is mean.
What kind of mean?
It's called population mean.
Exactly. Mu is the population mean. That means you have to consider all possible values to find the mean, this mean, which is expected value of x. And sigma is also population standard deviation. No sample is considered here. So how do you find the probability that z is less than 2.5?
From the chart.
From the
Chart. Normal distribution chart, right?
So let's look at the chart. We have a table here in the appendix. Let me show you how to read this table. Yeah, here is the table, I guess. There are many tables here. We will look at the Z table. Standardized normal, variate. This is the Z table. How do you read this table? Okay, let me. Huh?
You
We
can
can't
see it.
see.
You can see
See, Professor.
You cannot see. What can't you see?
the table.
Can you see this graph?
No, Professor. We can see the Word
So you have
document.
to see the Word file.
Oh, okay,
Yeah.
okay. I see. I see. I see. Sorry, I forgot to share. It's a new share now. Can you see now?
Yes.
Yes, Professor.
All right. Can you read these tiny numbers?
Yes.
I hope. So
Yes.
okay. So how do you read this table? Z table I will show it today. Any questions I'll answer today. Next class I will not answer because you have done this thing in the probability of statistics class. So any table you see, they explain it in the graph here. Okay. So look at this shaded area. Remember, this is the density function of that standardized normal, which is a bell-shaped shape, and from 0 is the mean. Remember, standardized variable mean 0, variance 1. So 0 is the mean, and from 0 to this side, the probability is 0.5. Area is 0.5 under this curve. And this area is also 0.5 and perfectly symmetric distribution. So let's focus on this area. What is this area? This area is telling you probability that Z lies between 0 and 1.96. This area is giving you the probability that Z lies between 0, this mean, and 1.96. Here you see. Probability that 0 lies between, Z lies between 0 and 1.96 is here, 0.4750. 0.4750. Where is that? Here. Now, this is how we are reading it. Here is the part of the Z values. Starting from 0.0 to 0.1, 0.2, and so on, 1.0, 1.1, and 1.9. Remember this 1.96? So you have 1.9. Where is 6? 6 is here, 0.06. So 1.9 you add with that 0.06. What do you get? 1.9 plus 0.06. If you add them, you get 1.96. So you come down with the this
0.4750.
here this row and this column intersection, this 0.06 column and 1.9 row. Here this is the value 0.750. that is given on the graph. Yeah, 0.4750. So that's how you get an area. You want to find a probability of an area, you look at the table like this. And so if this is the area, that is giving you the probability that Z lies between 0 and 1.96, which is 0.4750 from the table. What is the probability that Z is bigger than 1.96? This area, okay? Here, you are going from this side to that side. The value of Z is increasing. So Z greater than 1.96 is this area. However, what is this area? This area, the whole area to the right of the mean 0 is 0.5. So the whole area is 0.5. If it is a 0.5 and the shaded area is 0.4750, what is this area then?
0.5 minus
0.5
0.47.
minus 0.4750, which is 0.025. Any questions about this? Others, please speak out.
Professor,
Yes.
can you repeat again? What did you say? Something about 0.5? The
Yeah.
audio is not clear right now.
Right now, this is the area 0.47. What is the whole area to the right of 0?
0.5.
0.5. Because 50% of the probability is to the right. So it's 0.5. Now, if you have this area, which is 0.4750, what would be the rest of the area? How do you find the rest of the area?
We have to subtract
0.5 minus the value.
0.5 minus this value, 0.47. That is the probability that Z is bigger than 1.96. This area. See, here Z is bigger than 1.96. Okay. Any other questions? No, I guess. As this is a very symmetric distribution, from the equal distance from 0 to minus 1.96 will be this distance, and from equal distance will be to the left minus 1.96. What will be the probability that Z lies between minus 1.96 and 0?
minus 0.025.
Huh?
Minus 0.025.
No.
No, 0.4750, right?
So here you have minus 1.96 and you go and another shaded area, that area will be exactly equal to this shaded area.
So we have to add.
So probability that Z lies between minus 1.96 and 0 will be exactly
0.95.
same as probability that Z lies between 0 and 1.96, because this is perfectly symmetric. This distribution is a perfectly symmetric distribution. So if once you know the probability that Z lies between 0 and 1.96, you at the same time you know that probability that Z lies between minus 1.96 and 0, exactly same. Once you know that probability that Z greater than 1.96, do you know the probability that Z less than minus 1.96?
Yes.
Here.
Yes, Professor.
If it's here, see, for me, I always draw a graph to know which area you are looking at. So if minus 1.96 here, then you are looking at the left to minus 1.96, which is same as right to plus 1.96. So if probability that Z greater than plus 1.96 is 0.025, probability that Z less than minus 1.96, if it's here, would be 0.025. Try to draw a graph of this
Professor?
symmetric distribution. Yes.
I have a question. Like in the example you showed, Like we have to find probability z less than 2.5. How are we going to do that?
Okay, that is the question. That's why first, do you understand how we read this table?
Yes, yes.
Let me see. How many yes? Everybody yes?
Yes, Professor.
Yes,
Yes,
Professor.
Professor.
If there is a no, please raise your hand or tell me. Tell me. I'm looking at,
Professor,
who is this?
Arnika.
Ornika. Yeah, Ornika, tell me.
Professor, I didn't get where did you get that 0.9?
Huh?
0.9. That whenever you
I never get any 0.9. Where is 0.9?
maybe it's 1.9. Yeah, 1.9.
Yeah, it's here. Huh? What is your question?
Yeah, then why did you get that 0.6? Actually, my question was where did you get that 0.6?
So what are we doing here? We are looking at this 1.96, okay?
Yeah.
0 to 1.96. How do you find 1.96? The table is arranged such that the first two numbers here, 1.9 is on this column, first column, okay?
Yeah.
So then where is 6? This 0, where is this 0.6? They are here, okay?
Yeah, Professor, I got it.
So here is 0.06. So you add 1.9 with 0.06. That's how you get 1.96. Any other questions?
Professor, from minus 1.96 to 0, the probability will be 0.4750, not negative value.
Eh?
No. From the z value, from minus 1.96 to 0,
Yeah.
the value is going to be 0.4750.
The probability, yes.
It is a positive value, not a negative value.
Probability can never be negative. Can it be negative?
No, it cannot be negative.
Probability lies between which
0
two
and 1.
values? As 0 and 1. It
1.
can never be negative. If you end up with a negative probability in the exam hall, you tell me, Professor, something is wrong in my calculation. So I know that you know what probability is. Okay?
Can Z value be negative?
Yeah. Is that a normal distributed variable?
Yes.
And the range of normal distribution is what?
Plus to minus range.
Huh? What is the range for
Minus infinity to infinity.
plus infinity? Does that answer your question? Whether Z can be negative or positive?
Yes.
Z can be positive, negative, but the mean is what?
Mean is
Eh? Mean of the Z value is
0.
and at this point the distribution is just equally divided into two parts. 0.5 probability this side, 0.5 probability left side, and perfectly symmetric distribution. Any point here to the right 1.96, and with equal distance there is minus 1.96, and obviously the area under this 0 to minus 1.96 is exactly same as area under 0 to 1.96. That's the perfect symmetricity of the normality. Any other questions regarding the table? How you read the table? Huh?
No,
No.
Professor.
No. For me, I always draw a graph when I am doing the problem. That makes life easy. That makes mistakes less possible. Probability of making mistake reduces if you draw a graph. Okay, so let's go back to our example. What do we want to know? We want to know that probability that z less than 2.5. Okay, so 2.5. Where is 2.5?
Have it directly in the in the graph. It should be somewhere here.
Which area we are looking at? First thing, where is 2.5?
On the right hand side after
Huh?
1.96.
On the
It's not in a single area. It's in a
here,
blank
somewhere
area. The
here,
right-
okay?
Yeah.
It's to the right of 1.96. And which area we are? So let's say this is here. Can you see the cursor?
Yes.
Yeah.
Let's say 2.5 is there. Which area we are now looking at?
The entire left hand side after 2.5, right?
Yeah, so to the left of 2.5, the whole area. First, you have to be clear about it. To the left of 2.5, that means from here to all the area to the left. Now, this table is arranged such that it gives you the value for only one side. Okay. So first find this area from 0 to 2.5. Do you know how to find from 0 to 2.5? Hello?
Yes.
Yes. Where
We
is
have
2.5?
2.5 in the table.
2.5 is here. And
0.493.
here is 0, 0. So you add 0.00 with 2.5. That means you are looking at this point, this probability. What is the probability?
0.4938.
0.4938. Somebody write it down, please. I'll ask you later on. So 0.4938. Who is writing?
No, sir, I'm writing.
Yeah, okay. So you have found this area to the right, okay? From 0 to 2.5 you got. That is 0.4938. You got this part. But how about this part? This whole area is still there. What is this? What is this probability?
0.5.
0.5. So you add 0.5 with 0.4938. Okay.
0.993.
Okay. Now tell me, which is 0.5 plus. Now tell me 0.4.
493.
3,
8.
8. And that gives you 0.9938. So this is the probability. Question. Hello.
Yes, Professor.
Anybody got any question about how to find this probability?
Professor, can you explain the part after plus 0.5?
Yeah.
From the part adding 0.5 to 0.2938. Can you explain that part again?
So your question is why there is this 0.5?
Added in 0.
Why is that added?
Yeah.
Okay. Because this table is such that this table is only giving you probability of one side, this side. It's not giving you the probability of that side. Okay. So when you are using this table, it's not the same case for other tables. If you read another table, you will see that the whole area is given in some other tables. But this table is giving you only right hand side. But once you know the right hand side, you also know the left hand side because it's symmetric. So when you found this 0.4938, what is this value giving you? Huh? Hello?
Yes, Professor.
What is this value giving you? This value, okay, let me write it. Huh? So I could write it like this. So to make sure, minus infinity. Where is there an infinity somewhere? Sorry. So let me write it this way. It's minus infinity. I cannot find the infinity less than z less than 0, one part, plus probability 0 less than z less than 2.5. Is it true? Huh?
Yes, Professor.
So basically, when you are saying z less than 2.5, you are saying that actually it starts from negative infinity to 2.5. So we divide into two parts. We don't have to divide. We have to divide it here because our table is like that. Your table is here is giving you only this part. This part is not given. So I separated that. I said, hey, this whole area is minus infinity to 0. What is the probability of that area? Hello?
0.5.
0.5.
0.5.
0.5. That is this 0.5. Then I found the probability that z lies between 0 and 2.5. And that is this side area. Not 1.6, but 2.5. So that area we added, which is 0.4938. So I added these two to get this probability, which is 0.9938. Question? Hello? You guys have any questions? If not, can you find that this probability? Huh?
Yes.
Which one?
The rest two you gave those.
Huh?
The question you showed us
Yeah,
before
here.
that
Please
one.
do this. Please do this. Everybody, take a pen or pencil, a notebook. Do this. I will ask you.
Professor, can we see the question again?
Huh?
Can we see the question again?
The question. Here. So do B and C.
Professor, we can see the question.
Oh, okay. I'll shift the. Can you see now? Hello?
Yes, Professor, you can see.
Can you or can you can't?
Professor, we can see.
Okay. Go ahead and do this B and C. If you need the table, you take your book or tell me. First, you write this thing, okay? So I'll open the table for you. You write these things in a notebook. You should be able to write it in 1 minute. Mu is given, sigma is given, then you write B and C. Okay. Can I now switch to the other? Switch to the table. Please write it down.
So we have written.
All right. Is there anybody who did not write? Raise your hand. I'll go and ask how you did it and how you read the table. Okay, now I'm going back to the tables. Yeah, if you need, you can take a look at this table to find the values. I'll give you 5 minutes. I'm giving you 10 minutes to do these two problems. Looking at the table, find the values, and I'll ask
Professor, can you show the question once more?
How is it going?
Professor, I did, but I'm
Okay.
not sure.
Okay, wait a little bit. Let others also finish. Okay. How is it going? Did you guys get it? Hello?
Yes, Professor. Confusing.
It's confusing?
Yeah,
Yeah.
because there is a greater than sign over here.
Oh, I see.
So
Greater
what
than
I
so.
did is, Professor,
Greater than sign is,
I subtracted it
yeah. What did you get?
to remove the minus. But I'm not sure if I did it correctly.
What did you get? How much did you get?
My final answer is 0.0122.
Wrong.
One answer, and I did it in another way and I got 0.8778.
Wrong.
That's also
Professor,
wrong.
No, there
I
cannot be.
did.
See, it's a math problem. You cannot get two answers if
No,
you
no,
do.
Professor, I did it in two different ways because I was not sure.
Whatever way you do, you should get the same result.
Yeah, yeah.
As long if you are correct. If you are wrong, you can be wrong in many ways. Okay. So others, I'll go and ask. Fahima. Fahima Beg. Please respond. Fahima Beg. Fahima Beg. No response. Himo. Himo. Who is Himo? Himo?
Yes, Professor.
Yeah. So first one, what did you get? Hello? You don't want to speak, Himo? Okay. I see. Alpana Akhtar. Mosammat Alpana Akhtar. Hello?
Yes, Professor.
What did you get?
Professor, first one. Yes, Professor.
What is the result for?
4878.
What is that?
Continuing.
Say it again. How much did you get?
Point.
Yes.
Professor, I'm not sure.
Professor, she said
Alpana
0.2%.
Akhtar. What did you get?
4878.
4878.
Yeah.
Point what?
4878.
Wrong.
Professor.
Shami Akhtar Shukhi. Hello?
Professor, can I say my answer?
Huh?
Can I say my answer?
Can you say what?
My answer.
Yeah, go ahead.
Is it 0.9878?
Exactly. It's 0.9878.
I got 0.9861.
61 is okay, but yeah, it's also tolerable. It's okay. Okay.
As far as 0.98 is okay, right?
If anything close to 0.987 should
Yeah,
be,
okay.
I would say. But see here, the number is not important. How you find it is important. The process of getting it. Okay. So what did you do? Let me go over it again. There are two ways, I guess, to do it. But first thing first. What is the probability that x is greater than what? 21. Huh?
Yes.
Professor.
So 21, you convert that into z. 21 minus 30 divided by 4.
Yeah.
So what do you get?
Are
Minus.
you doing
Yes.
that?
Minus 2.25.
No, don't say anything now. 21 minus 30 over 4 equals minus 2.25.
Yeah.
Okay. Now you want to find the probability that z is greater than minus 2.25.
2.5. Yeah.
If you do up to this, you are done 80%. Probability that z is greater than minus 2.25. Now, can you see my table? Can you see the table now?
Yes, Professor.
So minus 2.25 is somewhere here to the left. Okay? Minus 2.25. That means you have the whole area to the right of that.
Yes.
Minus 2.25, and look at the whole area to the right. It's a huge area. It has got two parts. One part is the whole, this area, okay? The whole area. What is that area?
0.5.
0.5. One part is 0.5. Another part from minus 2.25 to 0. this area. Okay, you stop me if you don't understand. So first area is the whole area that you have to add 0.5. Another area is minus 2.25 to 0. Now minus 2.25 to 0 is same as 0 to 2.25. Is that right?
Yes.
Yes, Professor.
So somebody write it down. First part 0.5 because of this whole area. Another part minus 2.25 to 0, which is probability wise, which is same as probability of 0 to 2.25. Now what is 0 to 2.25? 2.25, 2 here, 2.2 here, okay? 5,
That is
5 from here,
7.
5 from here, this column. So 2.2 and you go all the way to this 2.25. The intersection of this row and that column is 0.4878. So 0.5 plus 0.4878. What do you get?
0.9878.
0.9878. Question.
Professor, I did like from 4.4878, but I didn't add 0.5. That's the problem.
That's why
I got
that's why I always tell you, draw a graph. Put 0 in the middle. Here. Draw a small graph, put 0 in the middle, write this and say here is 0.5, here is 0.5. Okay. That way.
Professor,
Yes.
Professor, if it is like in the left side, from the left side onwards, it is 0. Is it in the left side? Isn't it supposed to be 0.5 minus 0.4878?
No, it's not left side or right side. It's which area you are looking at. If it's here, okay, minus 2.25, and you are looking for the probability that Z is larger than minus 2.25, then you are looking at the whole area. But if it was like Z less than minus 2.25, then you would only look at this small area.
Like, Professor, even for that side, like even if we look at right side, like for example, we are trying to find the value of minus 2.25 to 0 for
Yes.
probability of Z.
Yeah.
So isn't it going to be 0.5 minus 0.48?
No. Once again, that's what we did. We said here is two parts. One minus 2.25 to 0. Another part 0 to plus infinity. Okay. When you have minus 2.25 and you are looking at the area bigger than that, probability bigger than minus 2.25, then you have two parts. One from minus 2.25 to 0, another one from 0 to plus infinity. From 0 to plus infinity, this is 0.5. From minus 2.25 to 0 is same as 0 to 2.25. That's what we did. If
Yes,
you had
Professor.
written down what I have said.
Professor,
Yes.
I have a question. Like
Yeah.
while I was in school, we used to do that. Like when there is a negative sign, we used to subtract it from 1.
No. Don't go by any thumb rule here. Okay.
Okay.
That is also possible. Then your table was giving you the whole area.
Okay.
Here our table is giving only what?
Till
Half of the area, not
half
yeah,
of the area.
half of the area.
Yeah, I get it now.
But this area is same as that area, so no worries.
Yeah.
So at this level, you guys are graduating. Now, any table you see, you should be able to read
Yes.
because the tables are self-explanatory here. Graph and these two lines are telling you everything. Any other
Professor?
questions? Yes.
Professor, so like just to add it, like we just need to add it, like from minus, we just
You
need
don't
to
have to
remember that
add.
minus 2.25.
Yeah,
No,
here,
no.
yeah. In
Like
this
we
particular example, no, you first thing, what you do is you look at the area you are looking for. Okay, draw the small graph and see which area. Is the area bigger than 0.5 or less than 0.5? Identify that.
like in this example, as I was saying, like
Yeah.
from minus 2.25 to 0.
Yeah.
Then again 0 to infinity. I
Exactly.
understood the part 0 to infinity, but
Yeah,
like,
because here is because for this particular table. Okay, guys, excuse me for a couple of minutes. The IT people came to fix this thing, the cable. I'll be back in 5 minutes. Let me just talk to them and see. But hello, I'm back. Yeah. So, any other questions about the table? How to read the table? How to do the probabilities?
No,
Please draw a small graph of the table. That way you will avoid mistakes reading the table.
Professor,
Yes.
like one thing I wanted to clarify, like for examples like this, like from minus 2.25
Yeah.
to 0, if we had to find out the if we had to find out the probability, we can just find out like what will be the probability if it is from 0 to 2.25. So that will be equivalent to minus 2.25 to 0. So we can just add it.
If you don't add it, then you are missing the 1/2 part of the probability.
Like we should always remember that.
No, not always. You look at the you draw the graph, and you see which area you are looking at. Don't do it mechanically. That is the problem with our people. Their school teacher showed them our formula and they memorized it and they think it can be used everywhere. No, it's just the probability you are looking at. If it's minus something and greater than minus, like greater than minus 2.25. Remember, z in the middle of a z value is 0. So to the left is from 0 to minus infinity. To the right is 0 to plus infinity. So when you are looking at a probability that z is bigger than some minus value, then you are looking at a very big probability. But if you are looking at a probability that z is bigger than some positive value, then what? Then you are looking at a small area because you don't have already any negative values there. Anyways, you will get used to it. How about the next one?
so I got
Probability
0.3944.
0 point
3944.
exactly how you did it. Let's go over it. So you have one value 30, you have another value 30 35 one value 30, another value 35. So you are looking at the probability that x lies between 30 and 35. So you convert 30 into z, you convert 35 into z. When you convert 30 into z, that is
0.
30 minus 30 divided by 4 is 0. Okay?
And z
when
value
you are
is
converting 35 into z, that is 35 minus 30 over 4, which is 1.25. Everybody with me here?
yes.
Yes,
The
Professor.
one value is 0, another value is 1.25. Now, so probability that x lies between 30 and 35 is same as probability that Z lies between 0 and 1.25. Okay. Probability that Z lies between 0 and 1.25. So in the table is easy. 0 and 1.25. Where is 1.25? Here is 1.2. Here is 0.5. So 1.25 intersection of 1.2 and 0.05 is 0.3944.
3944.
Very straightforward. Any questions? Hello, I'm asking everybody how to convert an X score into a Z score and how to read the table. If you don't like this table, you can use any other table.
Professor,
But don't.
explain after we got Z value 0 and 1.25.
Hello?
Professor, we got the value 0 and 1.25, right?
Yes.
Then after, can you explain again?
So basically what you are saying is 0 to 1.25. Okay?
Yes.
So then you read this table. What is this table giving you? What probability? Here say look at what they did. They said 0 to 1.96 is what? Huh? Probability that Z lies between 0 to 1.96. How did you get that? In the beginning? Were you in the class?
Yes, Professor, it's 1.9 and then we go like
It's 0 to 1.96. You
yes.
go 1.9 here
1.9
and
and then
you go
0.6.
Okay?
Yes.
Exactly same way. Now you are saying instead of 0 to 1.96, you are saying 0 to 1.25. Okay?
Yes.
So we go here 1.2, 1.25, 1.2 and
0.05.
where is 5? Here,
Yes.
0.5. So 1.2, 0.5 intersection is this 0.3944. Clear?
Yes, Professor.
Any questions? Any other questions? How to read this table? Hello?
Professor, when we
No.
like
Huh?
Professor, when we get minus like 2.25, that time we find out the Z value and then add 0.5, right?
No. Now you are still in the formulas. Did you draw the graph?
I didn't.
You draw the graph. You find out the area you want to know. Or else, if you have some formula in mind, there's every possibility that you will make a mistake. You draw a graph, you try to find the area, minus, plus, doesn't matter. You look at the graph, you say, hey, what is the area I'm looking at? You shade that area. Then you see whether you have to add 0.5 or you have to subtract from 1 or whatever. Okay?
Yes.
If you don't draw a graph, if you make a mistake, don't blame me. Okay? Don't tell me that, Professor, you didn't tell us to draw a graph. I am telling you here. Very small graph for your own consumption. So if let's say right away, if I ask what is the probability that Z lies between minus 2.252 plus 1.96, what do you do? Minus 2.252 plus 1.96.
We add 0.478 plus
Professor, then we have
0.475.
Do it and tell me.
Professor, I already did.
Yeah, what did you tell me how you did it?
Professor, first I get like 21 minus 30 divided by 4, and I got minus 2.25.
Yeah, that's what I'm giving you. I'm already giving you that minus
Yeah.
2.25. So I'm telling you probability that Z lies between minus 2.25 to 1.96.
Yes.
Which area you are looking at?
It's 2.
Is it 0.96?
No, area. Give me the area in the graph. Which area you are looking at?
Professor, it's minus 2.25 to 1.96.
Yeah. So the area is in the middle, around 0.
0.29.
Huh?
0.29.
The area is 0.29?
Yes.
No, wrong.
It is
It is
0.9628.
0.96.
What is the probability that Z lies between minus 2.25 to 0? You already did.
0.4878.
0.4878.
0.4878. Then add that with the probability that Z lies between 0 to 1.96.
0.475.
You add both. And what do you get?
0.9628.
Exactly. So basically you are looking at this middle area. Okay? Always look at the area. Which area you are looking at. That is very important. Don't go by all those formulas you have in your mind. I'm not saying they are wrong, but if the table changes, then the formula may not work. Okay. Hello.
Yes, Professor.
Yes, Professor.
Any other questions? No.
No.
Okay. I'll give you one more problem. Here, quick. A couple of minutes.
Professor, we can't
Yes.
see.
We can see.
Huh?
We are seeing the
We're seeing the
table. We
table.
can't see the dot.
Oh, you are still seeing the table, so I'm gonna share this. Can you see it now?
Yes, Professor.
Yes.
Yes, Professor, we can see.
A radar unit is used to measure speeds of car on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at the random is traveling at more than 100 kilometers per hour? Very easy. Find it. I'm giving you 5 minutes.
Professor, can you show the table?
You need the table? Huh?
Yes,
Yes,
Professor.
Professor.
Okay. I'm sharing the table with you guys.
Professor, is that 0.8643?
Hang on. What did you get?
0.8643.
0.8643.
43.
Wrong. It cannot be that big. Do you have any sense of probability? 0.84 is a very big probability, where the mean is only where the mean is only what? 90. And
Professor, is the answer
0.1587?
1587?
yeah. So you did not draw the graph. That's why you don't know which area you are looking at. You were looking at the wrong area.
Professor, can you show the question again?
No. Why? You didn't write it down? If you don't write it down,
the question. I started
it
solving the
doesn't
sum,
make
but
any sense to do the problem. Okay, I'm sharing it again. Don't do it like that. You first look at the problem. Okay. Here. Can you see the problem? Hello? The question? Hello?
Yes, Professor. Yes,
So
yes.
mean is 90, mu is 90, standard deviation is 10. Simple. And what is the value you are looking at? 100, greater than 100. So what do you get? 100 minus?
90.
Yeah. Is
Divided
equal
by
100 minus 90 divided by
10 equal to 1.
10. What do you get?
1.
You get 1. And then so basically what you are looking at is so you are looking at this probability that z is bigger than 1.
1.
Everybody with me here?
Yes.
Professor.
Probability that z is bigger than 1. Remember that. I'm going back to the table. Where is my table? Here is my table. Okay. So which area you are looking at? Let's say here is 1. So which area you are looking at?
Right side.
To the?
On the right. To the right.
To the right. Now, to the right is not given here. What is given?
Within 0. minus
0
0.5
to 0 to 1. 0 to 1 you can find. You cannot find more than 1. So you find 0 to 1. If you find 0 to 1, then you know that
Minus.
0.5 minus
0.5.
that area would be what you are looking at. So 0 to 1. Where is 1? Here is 1. Okay. Which is?
0.3413.
0.3413. What is this? This is the probability that z lies between 0 and 1. The probability that, so basically area, this shaded area, okay? If it was 1, then it would have been the area which is 0.3413. Now, if you want to find the area to the right of that, what do you do?
Subtract it from 0.5.
You just subtract this from 0.5 because this half area is 0.5. So 0.5 minus this area is what you are looking at. And what did you get?
0.1587.
0.1587. Yes, something like that. Makes sense. If somebody gives like 0.8, then you don't have any clue what probability means, what a normal distribution means. When the mean is 90 and the probability that some value is bigger than 100 cannot be 0.8. It can be 0.15, 16, maybe 13, somewhere around that. It cannot be like a huge value. No, you have to think about normal distribution. All right, guys. I will try to throw some examples so you can practice at home, and we come back. By the way, any issues with the textbook, with the recording, with other lecture note attendance, please contact the TA. She's there to solve these issues. All right.
Professor, even for the textbook, because you're supposed to send the textbook.
Yeah, because this is a PDF. This is a PDF, so she should have. Or if she doesn't have, then I think I shared the book with her as well. Okay.
Yes.
All right. All right, guys. For today, I would say it's a day because the IT people are here to fix some of the issues with the internet. I need to talk to them a little bit. Any questions so far? What we did today? Very simple things we did today. Everything you did in the probability statistics, but it's just to refresh your memories. These are important things. Okay, let me give you one more problem, and you try at home. If you here. Okay, let me throw that down here. Okay. Here, write it down. Do it at home when you have time. And I will ask in the next class. I will ask somebody to, I'll just pick one and ask you to explain what you did and how you did the table and all this. Please write it down. And let's finish this class. You write it down, and we'll see you next week. Okay, I'm ending the meeting.
Thank you, Professor.